So now let us start a new chapter. This is on kinematics of fluid. Kinematics deals with the motion of a fluid particle without knowing what are the cause of motion. So it deals with the velocity, acceleration, streamline, streak lines, path line, etc. to have the flow visualization. In fluid mechanics, there is one challenge because particles are not closely attached to each other. So these particles can have different type of motion. So to have it in a proper context, we use different techniques of flow visualization. Sometimes these flow visualization techniques helps us in developing suitable governing relationship or explaining the phenomena or finding out the point, etc. with the help of pictures or some flow visualization techniques. So in kinematics we deal with the flow visualization, velocity, acceleration, total acceleration, etc. If you talk about the any field in any zone, it can be divided in two known terms. One is known as scalar and one is known as vector. The scalar term is used for defining the property without having its direction, its magnitude only. Like in this room, if we define the density, then density can be defined with the help of one term. If we want to define the temperature, then define the temperature, so we don't need the direction. We can define with the help of magnitude only, right? But if we want to define velocity, force, acceleration, in that case those are known as vector. So we have a scalar field, we have a vector field. The terms which are defined with the help of a scalar are known as a scalar field. The terms which are defined with the help of vector are known as vector field. Now as far as the fluid motions are concerned, there are two methods. One is known as Lagrangian method, which was first studied and developed by Italian mathematician Joseph Louis Lagrange, who lived from 1736 to 1813. His idea was Lagrangian method. In Lagrangian method, we observe the fluid particles over the time and then do its analysis that what is the velocity, what is the acceleration, what is the temperature happens to that particle when it moves from one location to another location. So in this case we follow the particle and observe it over the time. This has its own challenges. Like in this case we will have to use large number of equations in case of fluid mechanics. So there is another approach which was developed by Euler. Euler gave this idea, who lived from 1707 to 1783. Euler gave idea that instead of following the particle, let us follow the points in flow region. So some points are fixed and we investigate the velocity, temperature, pressure, acceleration, etc. at those points only. So when we don't follow the particle, we observe the values at a point, that is known as Eulerian approach, and if we follow the particles in a flow regime, then that is known as Lagrangian approach. In Lagrangian approach, if we want to write it mathematically, then this is the equation. Position vector of, let us see this slide, position vector S is representing that particle which is identified by S0. S0 is identifying factor for this particle which is at this location at this time. So at time t, this particle is having this position vector S bar, which is represented mathematically as S naught. S naught is representing the initial position or identify that particle, and T is representing the time at which the position vector of that particle is S bar. If we want to write this equation in a Cartesian coordinate system for 3 mutually perpendicular directions, then x is equal to x, x0, y0, z0, t, y is equal to y, x0, y0, z0, t, z is equal to this quantity, where x0, y0, z0 are representing what? They are representing S0, right. So, this S position vector can be written in this form also, Ix jy kz, where x, y, z are the x component, y component and z component of this position vector S, right. So, if we want to write the velocity, then velocity is equal to del S over del T for given that position. So, del S over del T, if we partially differentiate the position, then it gives the velocity, and if we want to know the velocity component in x direction, y direction, z direction, then this equation may be written in this format: u is equal to del x over del t, v is equal to del y over del t, w is equal to del z over del t for, and this x0, y0 and z0 is representing that point, position vector, identifying that point. And if we want to investigate the acceleration, then acceleration is equal to, acceleration is written as second derivative of the position vector. So, del 2s over del t square for that point which is identified as S0, and the equation for x direction, y direction, z direction component acceleration may be written in this format: Ax is equal to del 2x over del t square, Ay is equal to del 2y over del t square for that particle. Similarly, we can write Az.